So we've talked about properties of addition and properties of multiplication. We're actually going to merge those things together in this next property, a single property called the distributive property. Something you've probably heard of and worked with and may be familiar with, but maybe you don't know why it's important. Maybe you don't know what its real applications are, what it's useful for. And so that's why we're going to focus one video on just the distributive property. And sometimes it's even called the distributive property of multiplication over addition. So I'm going to show you what it looks like, and then we're going to talk about the why behind it. This is a common way you'll see the distributive property. And then in parentheses, you'll have some sort of addition problem. I'm going to use a variable here. I know we haven't talked about them a lot, but I'm going to use a variable x. All that does is represent some number. So x is representative of some number. 4, and then times, in parentheses, x plus 3. Now, one thing that we're going to learn later is that we can't just add x plus 3 because we don't know what x is. So we have to leave that statement as x plus 3. But what we have to do is we have to multiply the number 4 times whatever this answer is. Another way to do that is to distribute the 4, meaning we can take the number 4 and multiply it by each of these terms individually. We can multiply 4 times x, and we can multiply 4 times 3, and it would look like this. 4x, remember we write 4 right next to the variable to show multiplication, plus 4 times 3. Now I'm going to simplify this because we don't want to just leave it as 4 times 3. We want to do the multiplication. But I would say it would simplify to be 4x plus 12. This means multiply 4 by whatever number x happens to be and then add 12 to that result. And that'll give you your final answer. This is how you would do it for any number that x happens to be. So, you might say, well, what's the big deal? Well, here's a situation where it's actually helpful to us. What I want you to try to think of is a little mental mathematics here. Well, mental mathematics. I'm going to give you the problem 4 times 23. And I want you to try to pause the video and do that in your head. And then once you've done it in your head, see if there are any other ways you could possibly solve that problem. Other mathematical processes, tools, tricks. Try to be a little flexible. Try to think of things outside the box. And then come back here and watch some of the things I've heard my students say in the past. So the most common thing I see people say when this problem comes up is they go right to some mathematical procedure that they've learned. 23 times 4, right? You stack them, you write them like this. You do 4 times 3, which is 12. Then you do 4 times 2, which is 8, plus 1, which is 9. And you put that right there. That's a common way people do it. They're like, okay, it's 92. Well, that's great, but does anybody know really why that process works the way it does? How about we be a little more flexible with our thinking? What if we said, if I want to do 4 times 23, could I break the number 23 up into 20 and 3 and do 4 times 20? Could I multiply just 4 times 20 and then do 4 times the 3? Does that work? Well, 4 times 20 is 80. 4 times 3 is 12. And when then I add those two things, because again, 23 is 20 plus 3. If I add these two, I get 92. Oh, it's the same thing. Maybe some of you out there took another creative approach. Maybe you thought, boy, 23 is really close to 25, which is a nice number. So maybe you thought it did it like this. 4 times 23 could be done as 4 times 25, because 23 is equal to 25 minus 2. And then you did 4 times 2. So 4 times 25 is 100. 4 times 2 is 8. and you subtracted those. 100 minus 8 is 92. What we're doing is we are being flexible with our numbers. We are looking at the number 23 and saying, could I just write that in a different way? Could I think about it as 20 plus 3? Could I think about it as 25 minus 2? Could I think about it as, 10 plus 10 plus 3? Could I think about the number 23 in different ways and write it in different ways? And the answer is yes. You can do so much arithmetic, mathematics, flexibly, differently than the strict rule-following procedures that your teachers often tell you to do. So, how does this apply to the distributive property? Remember how our other properties were simply alternatives for how to do a problem based on the original order of operations? Well, look at this. We have 4 times, and then in parentheses, 20 plus 3. Normally, you would follow the order of operations, the grouping symbol, and say, well, I have to add the 20 and the 3 first, right? I have to add 20 plus 3 to get 23. And then I have to multiply 4 times 23. And you could do that, which would give you 92. Or, and this might be easier, you can distribute the 4. Remember how I said it's often multiplication over division? Or multiplication here, addition here. 4 times 20 is 80. 4 times 3 is 12. And 80 plus 12 is 92. Alternatives for doing the same problem. So the distributive property is when we have multiplication out front and 2 things added or subtracted in the parentheses. A times, we say the quantity, that's a word we often use, A times the quantity B plus C is equal to A times B plus A times C. And I can even write it without the dots. AB plus AC. Notice that the A got distributed to both terms that were inside the parentheses, and now you see it here and here. There's still addition, and then this would be a simplified way of writing it. So again, that's how we applied the distributive property. It helps us break down the parentheses. Sometimes it's nice to get rid of parentheses because it allows us to be more flexible with the rest of our problem. So that's how we apply the distributive property of multiplication over addition.